We're looking at this question. A survey is conducted of 50 people asking who likes coffee and who likes tea. So there are our two questions. It was found that 20 people liked both, 15 people liked coffee but not tea, and 10 people liked tea but not coffee. Devices are shut to 30 degrees now, please. So, I'd like to ask particular people to tell me an important bit of information that we should underline. Misha, an important bit of information that I should underline, please.
There are 50 people altogether.
50 people. Another important bit of information, please, James.
20 people like both.
20 people like both. Another one, please, Mary.
15 people like coffee but not tea.
15 people like coffee but not tea. Another one, please. Who have I got? Michael. 10 people like tea but not coffee. Is there anything else we should possibly consider sort of important in there? Edward? Who likes coffee and who likes tea? Now we probably would have got that from this information, but it's a useful thing to look at. So we'd like to make a Venn diagram to show us this information and to help us work out some of the other stuff. So our Venn diagram gets a rectangle with two overlapping circles. And the positive answers to the two questions go on our two circles. So what am I going to label this this circle, please?
Like coffee.
Like coffee. And that goes on the outside. And what am I going to label the other circle?
Tea.
I heard one person give me an answer. What do we reckon? Like tea. So a Venn diagram gets labelled with the two positive answers to the questions, whereas a two-way table gets both answers to questions, positive and negative. So like coffee, don't like coffee, like tea, don't like tea. Now, we start putting the numbers in. What's a number that I can put in somewhere?
20.
20 in the middle, because if you can,
They like both.
always put the like both, or the people who are in both, in first. Do I have the total? 50. Where does the total go? Top corner, outside. Alright. 15 people liked coffee but not tea. So what number can I put in? 15, and where?
People like coffee.
Like coffee but they're not inside the like tea circle. 10 people liked tea but not coffee, so they go like tea. Now, trick question, and it's not really a trick question, but people do keep getting this wrong. So think about it before you answer. In total, how many people like tea? 30. The people in the middle like tea too. Don't exclude them. So 30 people like tea. So where would I put the 30?
Down the bottom.
Not down the bottom?
Next to
like tea.
Someone spotted a problem. The 30 goes there. What's the problem?
That it equals up to 45.
So?
It equals all three numbers in the
That equals 45. 15, 20, 10. What happened to the other 5 people?
They don't like you.
They are caffeine haters. And the people who don't like either go down here. I don't know, maybe they like Diet Coke, but we mustn't judge. So this is the one who doesn't like either. And now there's only one more total I need. So don't be tricked by this question again. In total, how many people like coffee?
35.
Good. Now that's the problem that people are going to keep on coming up against. Don't leave these people out, but, Riley, don't count them twice. If I said, well, 35 people like coffee and 30 people like tea, so that's a total of 65 people, what have I done wrong?
You're wrong.
I counted these people twice. All the coffee lovers, all the tea lovers, these people put up their hands twice. They don't get to be counted twice. They're not special. So if I want to get the total, I've got to count just coffee, both, just tea, and neither. Or of course I look up here. But that plus that plus that plus that should add up to the total. Now I do need to be able to answer questions from a Venn diagram or a two-way table. So find the probability, write this one down for me. Find the probability that a randomly chosen person from this group of 50, and let's find a few.
Randomly chosen.
So this was, I surveyed 2 classes, this class and next door, and then I'm going to randomly pick someone and say, huh, you get a coffee. Well, what's the probability that they actually like coffee? Oops, I don't want that to be coffee, I want this to be tea. Tea. Now when we do the probability, it's the number of people who are in this group divided by the number of people it's out of, like normal probability. So, trick question again, how many people like tea? 30 out of how many?
50.
Does this simplify?
Yeah.
3 over 5. Now, likes tea and does not like tea. What's the word for that pair of events? Complement. Well done. So, if 3 out of 5 like tea, 2 out of 5 dislike tea. I could have got that from here, but that's harder. So everyone in that circle likes tea. Those guys don't like tea. Those guys don't like tea. That's 20 out of 50, 2 out of 5. But it's easier to get it with the complement. So, if I've got time, there's still other stuff we need to explain, but we might stop there and get you practicing with some Venn diagrams.